Hi there, and welcome to this lesson on Pure Mathematics 2. And in this lesson, we're on Chapter 2 and 2.1, how you find midpoints and perpendicular bisectors. And first of all, we'll be looking at how you find the midpoint of a line segment. So if you've got the line segment AB with endpoints A with coordinates x1, y1, and B with coordinates x2, y2, if you want to find the midpoint of that line, then it'll be that point there, and M is halfway between A and B. That means it's the average of A and B. So it'll be the average of the coordinates for the two endpoints. And what that gives you is that the midpoint M is equal to the two x coordinates added together, divided by 2, the two y coordinates added together, and divided by 2. Okay, example 1. Given that A, 7, 11, and B, 1, minus 3, are the endpoints of the diameter of a circle, find the coordinates of the center of the circle. Well, the coordinates of the center will be the midpoint of the line AB. So we are just using the formula in the normal way. I'll let you have a go at doing that. So pause the video, have a go, and then come back to me when you're ready. Okay, let's have a look. So C is the center of the circle, and it is also the midpoint of AB. There are no tricks or catches in this. The coordinates of C will be the two x coordinates added together, 7 plus 1, and divided by 2, and then the two y coordinates added together, 11 plus minus 3, divided by 2. That gives us 8 over 2 and 8 over 2, which gives us 4, 4 for the coordinates of the center of the circle. Okay, example 2. Given that AB is the diameter of a circle with center minus 2, 5, and that A has got coordinates 6, 13, find the coordinates of B. Now, it's a little bit more tricky, this. I'll get you started just by saying that it's a good idea to let the coordinates of B be, it doesn't matter what these are, it could be x, y, but I'll call them little a and little b. And then you do still just use the formula in the normal way. I'll let you have a go at doing that, so pause the video, have a go, and then come back to me when you're ready. Okay, let's have a look. So this time we know the answer. We know what the coordinates of the midpoint are. The coordinates of the midpoint are minus 2, 5, the center of the circle, which is the midpoint of the line segment. Well, that means that minus 2, 5 must equal the two x coordinates added together, divided by 2, and then the two y coordinates added together and divided by 2, which is why we called this point AB. So you get 6 plus a over 2, 13 plus b over 2. Both of these we treat separately. So we look at the x-coordinate first and then the y-coordinate. Looking at the x-coordinate, that means minus 2 must equal 6 plus a over 2. We just solve that. Gives us minus 4 is 6 plus a, which means that a is minus 10. Then we do the same for the y-coordinate. So 5 must equal 13 plus b divided by 2, which gives us 10 is 13 plus b, which means b equals minus 3. Now I know the coordinates of the point B. So capital B has coordinates minus 10, minus 3. Okay, the perpendicular bisector of a line segment. Well, there's two words there, perpendicular and bisector. Bisector means that it's the line which is going to pass through the midpoint of AB. It's going to bisect AB. That means cut in half. So it's a line that has to go through the midpoint, and it's got to be perpendicular to the line. So it's got to be perpendicular to AB, which means it's got to be at right angles to AB. So that's the perpendicular bisector of the line segment AB. Now, we learned in a previous lesson that if the gradient of AB is equal to m, then the gradient of the perpendicular bisector will be minus 1 over m. Let's have a look at an example. Example 3. Given the line segment PQ, where P is equal to 3, 5, and Q is equal to 7, 13, find the equation of the perpendicular bisector of PQ. So there's PQ. The perpendicular bisector will be the line that cuts through at 90 degrees through the midpoint. I'm going to find the equation of that line in the form y equals mx plus c. That means I need to know the gradient of the perpendicular bisector, which will be minus 1 over the gradient of PQ. And to find c, I'll need to know a point on the line. Well, the point on the line that I'm going to be using is the coordinates of the midpoint, and I'll use that to work out c. Okay, I'll let you have a go at seeing if you can make sense of all of that. So pause the video, have a go, and then come back to me when you're ready. Okay, let's have a look. So there's the perpendicular bisector of PQ. To find the equation of the perpendicular bisector in the form y equals mx plus c, as we said, we need to know the gradient m. And in order to calculate c, we need to know the coordinates of any point on the line. Well, a point on the line will be the midpoint m, the midpoint of PQ. So I need to find the coordinates of m, and I need to find the gradient. First of all, finding the gradient of PQ itself. So the gradient of a line is given by the change in y over the change in x between any 2 points on that line. The change in y will be 13 minus 5, the change in x is 7 minus 3. That gives me 8 over 4, which equals 2. Now that's the gradient of PQ. I want to know the gradient of the perpendicular bisector. Well, the gradient of the perpendicular bisector will be minus 1 over that. So minus 1 over 2. That's the gradient of the perpendicular bisector. I also want to find out the coordinates of m, because I'm going to need that to find c. Well, the coordinate of m, that's the average of the 2x coordinates, 7 plus 3 over 2, the average of the 2y coordinates, 13 plus 5 over 2, which gives me 5, 9 for the coordinates of m. Okay, the equation of the perpendicular bisector of PQ is y equals mx plus c. M I know, I've just worked it out. It's minus a half. So that's y equals minus a half x plus c. The method for finding c is always the same. You need to know the coordinates of any point on the line. Well, I've just worked out the coordinates of a point on the line. M is on the line, where x is 5 and y is 9. So substituting in x equals 5 and y equals 9 gives me 9 equals a half times 5 plus c, which means that c is equal to 23 over 2. So in the form y equals mx plus c, the equation of the perpendicular bisector will be y equals minus a half x plus 23 over 2. Or if you wanted to tidy it up, it would also be possible to write the equation in the form 2y plus x minus 23 equals 0. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to pages 27 and 28 and have a go at exercises 2a and 2b. Thank you very much for listening, and cheerio.